All right, algebra break reasoning. Today we're going to be talking about multiplying powers of the same base. So what do I mean by that? Well, I'm going to start here with this right here. So if we give you 3 to the 4th times 3 squared, what does that mean? Well, we know what 3 to the 4th means. 3 times 3 times 3 times 3. 4 times, right? And what does 3 squared mean? 3 squared means 3 times 3, 2 times. So if we see that we have 3 4 times here, and 2 times here, well, that means we have a total of how many 3s? Well, literally, I'll count. 1, 2, 3, 4, 5, 6. Well, what did we really do? So this is, by the way, is 3 to the 6. But again, what did we really do? Well, what we really did is we took 4 and we added 2, which are our exponents, and 4 plus 2 gave me 6. So that is why the general rule is, and we're going to see it written in a fancy way, but it doesn't mean anything. If I give you a to the b times a to the c, where a is just a base, then that will equal to a to the b plus c. We're just adding b and c together. So if we look, let's look here at this one. So 9 to the 5th times 9 cubed. So if I see 9 to the 5th times 9 cubed. This is just 9. Well, if you have 5 of them in one and 3 in the other, then you have a total of 8 of them. So it's 9 to the 8th. And if we look here with negative 3 to the negative 2, let's write that out. Negative 3 to the negative 2 times, I think it was 3 to the negative 3 to the 10th. Again, don't let the signs scare you, okay? This just means we're going to add these. So this is just going to become negative 3 to the negative 2 plus 10, or negative 3 to the 8th. And later we will talk about another way of thinking about this, but for the time being, I just want to stress that when it's negative, when you multiply numbers, right, with the same base, you're going to add the exponents. So there was a question, I don't know if anyone was paying attention, that I glossed over, which is this one. So what is 2 to the 4th times 3 to the 4th? And the answer is 2 to the 4th times 3 to the 4th. And some of you may be asking, well, Mr. Anderson, why can't I just say it's equal to 2 to the 8th? Or why can't I say it's 3 to the 8th? Or maybe you just multiply the bases together and say, why can't I say it's 6 to the 8th? Well, I mean, think about it. 2 to the 4th means 2 times 2 times 2 times 2. And 3 to the 4th means 3 times 3 times 3 times 3. What can you do with that? There's nothing you can do there, right? It is what it is. So there's no like direct way to do that. Yes, I can manipulate these together. I can, for example, pair them and say it's 2 times 3 and there's 4 of them. I can do stuff like that, but there's no like direct way as we can with something like, say, 9 to the 5th times 9 cubed, or negative 3 to the negative 2 times negative 3 to the 10th. So what's very important here is that when you are adding the exponents, as you'll see in the rule that we just wrote here, the bases have to be the same in order to add the exponents. Let's look at the next question. So in the next one, we have 6b cubed times 3b to the negative 8. Now, there are a bunch of properties that we glossed over at the start of last semester, and one of those properties is the commutative property, which says we can rearrange according to whatever order we want when we just multiply. So I'm going to rewrite this as 6 times 3 times b cubed times b to the negative 8. And the reason I'm doing that is just to make it a little clearer on the eyes that 6 times 3 is 18. And then what do we do when the bases match up? Well, we're multiplying. Well, we can add the exponents. So this is going to become 18b to the negative 5th, which is fine to leave as that. Or you can rewrite this as 18 over b to the 5th. Okay. Well, let's look at the next one. So the next one is 4c times 3d to the negative 8 plus 2c cubed. And once again, I'm just going to pair the numbers together. So 4 times 3 times 2. And then I'll pair the letters. So c times c cubed times d to the negative 8. So I just, if they're alike, I put them together. And so from here, we can say that this is 4 times 3 is 12. 12 times 2 is 24. The c's, remember there's a 1 technically here, so this is c to the 1 plus 3. And then we have d to the negative 8. Notice I did not put my c's and d's together because they are not like terms. Then what? Well, then we're going to say it's 24, c 1 plus 3 is 4, and then we said when it's a negative, we put it in the denominator. And so now, I'm just going to clean this up once more. That's fine. I'm going to say it's going to be 24 c to the 4th over d to the 8th. And there's my answer. Okay? By the way, I am trying to show every single step as I work through it. You do not have to. If you want to jump straight to the answer, you can. Though if you are jumping straight to the answer and missing these, it's probably an indication that you need to write out each step. Okay? Let's move on. Now, this is extremely important. You're going to use these a lot in science classes, which is scientific notation. So let's do it. Using powers of 10 to write very large, very small numbers in a more convenient way, where a or the whole number must be between. So what this is saying is that when we write in scientific notation, the a value must be between 1 and 9. In other words, you can't write 10 to some power. It has to be 1 to 9. And so how do we write this in scientific notation? Well, what you do, let me rewrite the number here. So 25, 6, and then we have 3 zeros. Okay. So what you're going to do is you're going to take your decimal place and you're going to count how many times do you have to jump until you have a single digit. So we can see here we jumped once, twice, 3, 4, 5. I actually recommend writing it out so you don't make a silly mistake. Then you just rewrite the number with that decimal point inserted. And I can rewrite this as just simply 2.56 because the zeros don't matter. And we're going to multiply by 10. Now, however many times you jumped, that is what you're going to put as your exponent. And the beautiful thing about this is you can literally just type this into the calculator and see if it's true, right? Or we could actually implement it, which means I would just jump. I would take 2.56, and this is, if you get what's going on, this is a little silly, but I'm going to show it just to be clear here. You would jump 2, and then you would have 3 zeros, right? And that would be the same thing as the original number, right? And that's all you're doing with scientific notation. That is it, okay? Want to get really comfortable with this? It's not going away. You're going to use it in multiple classes. Let's go on to the next question. The speed of light is 3 times 10 to the 8th meters per second. How far would a beam of light travel in 8.64 times 10 to the 4th seconds? So let's see what we would do here. So one thing when you approach these questions that I think is really important, I'm not going to worry about 3 times, well, let me just write it. So it's going to be 3 times 10 to the 8th meters per second. We'll put the seconds in the denominator because it's meter per second. Okay. And we're going to multiply this. Well, I shouldn't say we are going to multiply, but why do you multiply it? You're going to multiply it by 8.64 times 10 to the 4th seconds. And the reason why you're going to multiply these together is because the goal of what we're doing here is if the seconds divide out, so seconds divided by seconds is 1, then all I'm left with is meters, and my final result will be meters. Now, so we're just going to have to multiply 8.64 times 3. You can do this on the calculator if you want to. It's easy enough to do by hand. 12, 18 plus 1 is 19, carry the 1. 24 plus 1 is 25. Now, because I have 2 decimal places, I jump 2 places over. And this is 25.92 times what? Well, we have 10 to the 8th and 10 to the 4th. And this is where we're going to use the skills that we've just learned, which is that if the bases are the same, what do we do with the exponents? We add the exponents. So this is going to be 10 to the 8 plus 4, which is going to give me 25.92 times 10 to the 12th meters. Okay. Now, we're not actually done. Because if the question was, well, we could technically be done, but let's say the question had asked us to put this in scientific notation. Notice 25.92 is not in scientific notation. The reason it's not in scientific notation is that it has a two-digit number. We said when it's in scientific notation, it has to have 1. So we want to jump the decimal place once more. So this is going to become 2.592 times 10. And if you don't believe me, multiply 2.592 times 10, and you'll get 25.92. I'm not just saying this to say it. What I'm saying is try it. If you're not sure if what you're doing is correct, try it and see what happens. Now the back side is going to be exactly what it once was. And we're left again, remember this is 10 to the 1. Since the bases are the same, we'll add the exponents, and we'll end up getting 10 to the 1 plus 12, which I'm not going to rewrite. It's 10 to the 13. And there is my final answer. Okay, let's move on. Exponents can also be expressed as fractions, and this is where it's going to get really interesting. So it says fractional exponents are called rational exponents. So recall that 3 squared means 3 times 3, which means 9. You can also write the same expression using rational exponents. So what's 9 to the 1/2 power? 9 to the 1/2 power is equal to b, indicates that b is a positive number that when multiplied by itself equals 9. In other words, 9 to the 1/2 power is the square root of 9. In other words, what number times itself gives me 9, which is, in this case, you can see here, is 3 times 3. Okay. You can also have expressions like 9 to the 3 over 2, which means 9 to the 1/2 times 9 to 1, 9 to 1/2. I don't actually like to think of it that way. I like to think of this. Let me write this 9 to the 3 over 2. I like to think of this as 9 to the 1/2 raised to the 3rd. And the reason why I like to think of it that way is I can tackle 9 to the 1/2. So remember, we just finished saying 9 to the 1/2 means what? It's the same thing as the square root of 9, or what number times itself is 9, which is 3. So I can take this inside part and rewrite it as 3. So it's just 3 to the 3rd, which is the same thing as 3 times 3 times 3. Do not say it's 9. It's going to be 27. And that's what they're saying down here. I think that's the easiest way to approach it. So let's do another example. The example they're giving us is 32 to the 1/5. So this actually means the 5th root of 32, which is, perhaps if you've never seen this notation before, is a little daunting. But all this means is what number times itself 5 times gives me 32. Now in time you will memorize this, but if you don't know right now, you just sit there and play with the first number, the smallest numbers possible, because if you're multiplying by itself multiple times, it's going to grow pretty fast. So obviously 1's not going to work, and if you're not sure why, just think about what 1 times itself 5 times is going to give me. Well, it's just 1 times 1 times 1 times 1 times 1, which is just 1, right? So clearly that's not going to work. So we'll go to the next one, which is 2 to the 5th, which is 2 times 2 times 2 times 2 times 2. So let's see what this breaks down to. And one of the things I'll encourage you to do is when you have to do this multiple times, sometimes it's easy to pair things. Like, for example, 2 times 2 is 4. So I just 4 times 4 times 2. We know 4 times 4 is 16. 16 times 2 is 32. Notice if you didn't like that, you could have also done 4 times 2, which is 8, and 8 times 4 is 32. Mix and match, make it work. But notice that it does work with 2. So we know that 32 to the 1/5 is 2. And that's it. this is where it gets interesting. So what is the simplification of 4 to the 3 over 2? So recall back here that when we did this, I broke it down to the first I dealt with the fraction component, and then I dealt with the exponent. So I'm going to do the same thing here. So this I'm going to rewrite as 4 to the 1/2 raised to the third. So what does 4 to the 1/2 mean? That's the same thing as the square root of 4, or what times what is 4? What times itself is 4? Well, that's clearly 2, so I'm left with 2 cubed, which is 8. And if you said 6, that's because you said 2 times 3. But it's 2 times 2 times 2, right? Well, so, or 2 cubed is 2 times 2 times 2, which gives me 8. Okay, number 6. Simplify the expression. All right, so what I'm going to do here is I'm not going to let the fractions scare me. I'm just going to pair things together. So I'm going to have 3a, actually, I'm going to put the numbers first. So we have 3 times 3. Then we'll do the a, so a to the 1/2 times a to the 3/4. Then the b, so b to the 1/5 times b to the 2/5. Okay, so numbers are easy enough. 3 times 3 is 9. This is the interesting part, but for now we'll write as a to the 1/2 plus 3/4. And then the other one is going to be b to the 1/5 plus 2/5. Again, you can put the bases, the exponents, you can add the exponents together if the bases are the same. Okay. Now, the back part's actually really easy. The 1/5 plus 2/5, because the denominators are the same, this is just going to be b to the 3/5, right? 1 plus 2 is 3, and then you do over 5. The interesting part is going to be here. So how do I deal with 1/2 plus 3/4? You have to get a common denominator, which gives me 5/4. So all this becomes a to the 5/4. We'll go ahead and bring everything else down. So we'll bring down the 9 here. And we'll bring down the b to the 3/4. So I said 3/4, 3/5. And that's my answer. Okay. So don't let the fractions confuse you. You're just tackling it like you would normally. Just because you see ugly things doesn't mean that it's that complicated. Okay. Last bit. I just thought this was a good summary. So again, when the bases are the same, you add the exponents. These are some examples of 1/3 plus 1/3 gives you 2/3, right? B to the 7th, b to the -3. Don't let the negatives confuse you. You're just adding the negative. It gives you b to the 4th. And there we have it. So I hope that this makes sense, and I'll catch you all in the next math video.